11.2 Arithmetic Sequences and Series. Okay, an arithmetic sequence is where terms are found by adding. And you're adding a fixed number over and over and over again. The common difference is that number that's being added. Example 1 says find the common difference D for the arithmetic sequence shown below. If you look at it, it doesn't take too long to see that it looks like you're subtracting 7. Minus 7, minus 7, minus 7, minus 7. It looks like you're subtracting 7 to get to the next number, but remember that we're talking about adding. So think of it more as adding negative 7. The common difference is negative 7 because we are adding negative 7. Number 2, find the first 5 terms of the arithmetic sequence. Well, the first term is negative 14, and the common difference is 6. So if we start at negative 14, and if we add 6, we're going to get to negative 8. And if we do it again, that'll be negative 2. Add 6, that's 4. Add 6, that's 10. So there we go. It's those numbers. Next one, you've got a decimal. A1 is 1.5, so that's where we start. And we're going to add negative 0.5. That's your common difference. So if you add negative 0.5, you'll have 1. And if you do it again, you'll have 0.5. If you do it again, you'll have 0. And if you do it again, you'll have negative 0.5. So again, all I'm doing here is I'm adding negative 0.5 and again and again and again. The nth term of an arithmetic sequence looks like this. And so you want to pay attention to the things that are shown in that formula. You would need to know the first term, and you would need to know n for the nth term. So if I'm finding the 99th term, then n is 99. And of course, you would need to know the common difference. So you need to know several things to find that nth term. Example 3 says find a16 and a sub n for the arithmetic sequence. So when you look at this, I can see a1 is 23. Okay, so that's my first term. And you can figure out pretty quick how to get to the next term. It looks like d equals negative 3, because it looks like we're subtracting 3, subtract 3, subtract 3. So if I want to find a16, that means n is 16, and I have everything that I would need to know. I've got a1, which is 23, plus, just look at your formula here, in parentheses you've got n, and that must be 16, minus 1 times the d number, which d is negative 3. Excuse me. So let's clean this up. That's 23 plus 15 times negative 3, or 23 plus negative 45, which is negative 22. So a sub 16 equals negative 22, or in other words, the 16th term in that sequence is negative 22. Okay, so now let's find a sub n. So we want to start with that first term, 23. But this time n is an unknown, so I'm just going to leave it as n. And of course your d number is still negative 3. So this is going to be an equation. You're going to have an n in it, and that's fine. Let's distribute the negative 3 there. A sub n equals 23 minus 3n plus 3. I see some like terms I can put together. A sub n equals negative 3n plus 26. All right, so you don't get a number, you get an equation. All right, this is an explicit equation, and it's kind of nice because you could just plug in an n number to find any term. If I wanted to find the 16th term now, I could just plug in 16 for that n right there, and you should get that answer. Okay, if I wanted to find the 99th term, I'd plug in 99 and so on and so on.